Welcome back to lecture series on hydrogeology. So in this lecture now what we are going to discuss about the chemical analysis of water. So for a geologist, normally we collect the water from the different geological terrains. As we know that the primary factor which controls the chemistry of water is the geogenic source. Different lithology controls the chemistry of water. The first step to be done, the analysis in the field itself is the assessment of pH, the temperature controlled EC, temperature controlled pH, and TDS. All this is very important parameter that has to be tested in the field, and then when you are coming back, even within 24 hours, if you do, it's quite better to assess the quality of water. Now let us discuss the various parameters of the physical characteristics. It has many uses, as I said. This can be related to soluble products of rock weathering, as I said, geogenic source. Decomposition changes with respect to time. Yes, how long the water stayed in a particular rock also decides the chemistry of water. The water analysis can interpret in this context with respect to hydrogeologist would be of better interpreter because as he knows the mineral characteristics, rock characteristics and the water characteristics. The groundwater analysis, we can trace up the direction and the movement of groundwater. Yes, it has done. Suppose now people have started utilizing isotopes. When you pour isotopes in Talai and you can estimate the distance, how long it takes to travel to the end point at Mayiladuthurai. So this is how we can trace even if it is thousands of kilometers. And you continuously take the water samples after a week, then you'll be able to get what is the movement what is it, what direction it moves and what speed it moves in the subsurface also can be assessed. The history of geology of the enclosing rock can be able to get water analysis of, yes, it is very important. As I said, geogenic source controls the quality of water. The hidden ore body, chemical analysis of water. Sometimes if you analyze the water, you will be able to assess the hidden ore body. Can also be predicted by conducting water analysis all along the streams. The ratio of calcium and magnesium may be useful in identifying waters of dolomitic rocks from those of limestones. Bicarbonate and chloride ratio is useful for seawater intrusion studies. The ratio of potassium and total cations is useful for the studies of natural base exchange movement in the. So chemical analysis has got a lot of applications. Once we study, we will be able to assess all these things. And apart from that, for irrigation, the water analysis report is essential. The amount of gypsum application to reclaim saline soil or saline salt water is mainly based on water treatment. Starting of an industry also depends upon the water quality of that region, so that it is possible to avoid scaling deposition of salts along the pipes and other places. Drinking water also to be tested before consumption to avoid the health hazard. Yes, it is very important. Nowadays everybody is very interested. Now we are going to discuss about the physical parameters of pH, EC, TDS and total hardness. And this part we will discuss in the subsequent classes. Right? There are two properties as the chemical analysis of water is involved with respect to physical characteristics and chemical characteristics. We will collect the water and then test for the first step of physical properties. And when you start doing by looking the glass, you see you will be able to see the the other side of it, very classical transparent. But your water should be like this for even drinking or the other uses. Let us now estimate the pH. Look at that how there is a video here. So pH is taken, pH generator, and the water is added. So this is bottled water, this is sparkling water, this is pH 9 generator. So it's being taken from the, you see this is being taken, and this is bottled water. If you put, that you just look at that. So this is pH is high 9 and this is pH is neutral, and this is sparkling water, pH is very less. So if it is less than 7, it is acidic. If it is more than 7, it is alkaline. This is the pH chart. The center portion is okay for us, and this is one of the most important indicator for water quality for pH studies. The pH scale, it normally runs from 1 to 14, and measures the acid at one end and base at the other end. 0.7 center point 7 is neutral, while reading below 7 is acidic and above is alkaline. The WHO and Bureau of Indian Standards, World Health Organization and Bureau of Indian Standards recommend pH between 6.5 and 8.5 for drinking purpose. Groundwater flows through rocks and soils that can be affect the water's pH level. For example, contact with sandstone result in nearly neutral pH between 6.5 and 7.5. Limestone, on the other hand, can result in alkaline pH of 8.5. Freshwater lakes and streams typically have pH levels between 6 and 8. And how you will estimate the pH? This is the pH buffer capsule. You can see the pH buffer capsules of different colors, orange, green and blue. It means when you use this, you will be able to assess what is the pH level of that particular. So, this color indicate the pH of standard solution, right? The pH buffer capsule is being used to standardize or calibrate the instrument. For this purpose, pH meters are used. Here known pH solution, these are all the different pH meters by different vendors, and you need to have all the other equipment like tissue paper, beaker, standard flask, wash bottle, forceps, magnetic stripe. All these are all the basic equipment for chemical studies. Using this known pH solution, this instrument is first exercised to correct the reading by using this. After that, the unknown water sample is used to getting proper results. Now you have to dip the water. This exercise has been teached only for the geologist to do the exercise how to assess the pH by using the pH meter. And you look at that, when you add salt, it shows that because of the conductance improved, and immediately that the bulb started blinking. So, the ability of water to carry electric current is known as electrical conductivity. The ability of water to carry an electric current is known as electrical conductivity. From this, an identification of its ionic strength is possible. Depending upon persistence of salt in the water, the conductivity of the water also vary. Right? Here, the presence of salt in the water directly proportional to the EZ value. If the salt concentration increases, the conductivity increases. You see the best example. If you are adding the salt, automatically the conductance are increased. If it is less, conductance is less. How will you estimate this? Conductance is a function of water temperature. Hence, a standard temperature, usually 25 degree centigrade, must be specified in reporting conductivities. The conductivity is the reciprocal of resistivity, ohms. Hence, it is expressed Mohs unit. Because it is a reciprocal of resistivity, the conductance are showing reciprocal of resistivity, it is being represented as Mohs unit. Normally, the water samples are expressed in micromoles per centimeter at 25 degree room temperature because mho is bigger unit. 1 mho per centimeter is 1000 million mho per centimeter, which is equal to 10 to the power of 5 micromoles per centimeter. Most natural water have conductivities much less than 1 mho per centimeter. The classification of water according to the pH value, you see that it is 4 category as excellent, good, permissible and doubtful, less than 250, between 250, 750, 750, 2250 and more than 2250. If it is less than this, what will be the result of it? Water of low salinity, because if salinity increases, conductivity increases. Is generally composed of higher proportion of calcium and magnesium and bicarbonate. This is moderate saline water having varying ionic concentration. This is higher saline water consists mostly of sodium and chloride ions, and here water containing higher concentration of sodium, bicarbonate and carbonate ions have higher pH value. And this is how we do with the assessment of electrical conductivity in the study. And coming to the determination of total dissolved solids, and how you are going to determine the total dissolved solids, this is 0, 0, 0. Once if you dip your instrument into the water, tap water, initially it has no value, but when you dip, you see you will be able to get your, the readings. 256 ppm is the total dissolved. Total dissolved solids is the total amount of solids in milligram per liter. milligram per liter. That remains when water sample is evaporated to dryness completely. If you evaporate and then check, finally whatever the amount you get, that is called total dissolved solids. There are two methods by which TDS can be determined. One is gravimetric and conductivity. TDS is always represented parts per million, and you see this is the TDS scale 0 to 50 and it goes up to 500. And normally it is classified that it is ideal for drinking purpose if it is less than 50. If it is 100 near 100, it is carbon filtration. Mountain spring water will have this one. People used to say it is little hard up to 170, and 200 is marginally accepted, and high TDS from the tap and mineral springs between 300 and 400. US EPA maximum contamination level they have kept up to this. So normally when we get the water, tap water, it will be between 170 and almost 320 30, right? So this is acceptable limit with respect to WHO and BIS standards. The second method is the gravimetric method, and in this method now how we are doing, pipette out, you have to take pipette out 100 ml of water sample, evaporate to dryness, you have to evaporate, finish the drying in an air oven 100 to 105 degrees centigrade, cool and dish in a desiccator and wait. Take the weight of it and then check. So this is how the procedure is here. You have to take the water sample and then try it, keep it over oven and assess with weight machine. And the total dissolved salt is express the results in parts per million. And this is how we do with the water TDS water by gravity meter. And the conductivity method, the conductivity of the sample is first determined by conductivity meter. This is a conductivity meter. Then the value is multiplied by 0.64 gives TDS of the solution. You will have to multiply this value into 0.64. That is TDS, which is equal to 0.64 into EC in micromoles per centimeter. And this TDS is classified into 0 to 1000 as fresh water, 10,000 brackish water, 1 lakh salty water, and more than 1 lakh is a brine water. Hardness in water is due to the presence of dissolved solids of calcium and magnesium. The hardness always represented by using these two parameters. It is unfit for drinking if it is of excess content of calcium and magnesium. You cannot use it for the purpose of bathing, washing, and it also forms scales in boilers. Hence, it is necessary to estimate the amount of hardness producing substances present in the water sample. Once it is estimated, the amount of chemicals required for the treatment of water can be calculated. The estimation of hardness is based on complexometric titration. Hardness of water is determined by titrating with standard solution of EDTA, that is ethylene diamine tetraacetic acid, which is a complexing agent. Since EDTA is insoluble in water, the disodium salt of EDTA is taken for this experiment. EDTA can form 4 or 6 coordination bond with a metal ion. Now this is the hard water, and when it is that the EDTA solution is taken in the burette and the sample is taken over here, and then you slowly add EDTA solution and then find the changes of the solution. The estimation, how this is being estimated, the two types of hardness is present in water. First is temporary hardness and second one is permanent hardness. Temporary hardness is due to the presence of bicarbonate of calcium and magnesium ions. It can be easily removed when you boil the water, automatically this will be removed. Permanent hardness is due to the presence of chloride and sulfate of calcium and magnesium ion. This type of hardness cannot be removed by boiling, right? This is how the estimation is done. And these are the different apparatus used, as you are well versed with the hydrogeochemistry. I think I don't need to explain this. And these are the different reagents like erythrome black tea solution pure and EDTA disodium salt hydrate, desilted water, ammonia buffer solution. And estimation of hardness of water by EDTA method. Take 20 ml of sample water into a conical flask. You take 20 ml of water, add 1 ml ammonia buffer. This is the procedure. Add 5 to 6 drop of erythrome black tea indicator. The solution turn into white red color, wine red color. Note the initial reading and titrate the content against CDTA solution. At the end of end point, color change from wine red to blue color. Then take the reading. Now take the final reading. Repeat the process till we get the concurrent value. And this is the hardness value. Soft water is lower in ppm and hard water will higher in ppm. And less than 17.1 is the soft water. And over 180 ppm above is the hard water. In between you have classes like slightly hard, moderately hard and hard. This is how the hard water is classified. This is how the study is done with respect to pH, EC, TDS and total hardness. With this the discussion for the physical parameters estimation of chemistry, chemical waters in terms of hydrogeology is come to an end. Thank you.